One of the most important steps in science is creating models. Models allow us to understand real-world problems, and they are a safe way to explore what might happen. You don't want to build a nuclear reactor without testing that it's safe. You don't want to do a bungee jump without knowing that you won't hit the ground. During COVID, we needed to use models to decide what to do. Models are very important in making policy decisions. And using models during COVID was important because we didn't have that much information. We didn't know what the disease might do, and we didn't understand how it might spread. Using models allows you to save money, and it allows you to make decisions quickly when you have limited amounts of information. Of course, there are arguments between different model makers as to which one of the models is the best. This is why we had several controversies during the pandemic. How do you go about constructing a model? First, you need to recognize a real-world problem. This could be how does the disease spread or what is the mortality rate? What you could do is build a mathematical or statistical model, either through using equations or simulations, which capture the things you think happen. For example, in COVID, we wanted to understand whether it was a droplet infection or airborne. What you can do is build models based on the two different assumptions and see how it spreads in the two different models. What you would do is use those models to make a prediction about what you would expect to see. Then you would collect some real-world data about how fast COVID spread, and then you would compare the model to the data. This would allow you to determine if it was either a droplet infection or airborne. Because the models give you different sets of results that you can compare to reality. If you build a model, collect some data and you find that the data doesn't fit the model, then your model is wrong. This was something that Richard Feynman stressed as important. Some scientists collect the real-world data, see that it doesn't fit with their model, and decide that they must have made some error in collecting the data and that the data is wrong. Instead, they should be thinking it's the model that needs to be improved and changed and not the data.